back with another video. Okay, so today's video is going to be quite brief. We're going to be looking at molecular compounds and molecular elements before we finish on further understanding really what is going on in combining atoms, as well as what is the force that keeps them together and what actually is keeping an atom structure intact. So the first thing that we're going to be having a look at is obviously understanding, once again, compounds versus elements. Now, the first thing that we need to make mention of is this sort of summary here, which I like to look at as a compound or a molecular compound is quite simply a combination of multiple atoms. So always keep in mind, when we're talking about molecules, we're not talking about single atoms or single elements anymore. When we talk molecules, we're talking combinations of multiple atoms. Now we have our two types of molecules. We have our molecular compound and we have our molecular element. So our molecular compound is just that, much like a compound, which you guys know, is just a combination of multiple elements that are different. So our best examples of those are water or carbon dioxide, CO2 or H2O. Then we see that a molecular element. Now we know an element we define as an element is quite simply an atom that has the same number of protons, or it has the same atomic number. So if we have a molecular element, molecular meaning multiple atoms, element meaning the same element, which means it is multiple elements combining that are the same atoms. So, example, oxygen gas or hydrogen gas, H2O or O2. Yes, we've got multiple atoms, but they are the same. So it's a molecular element. So always when you see these words, break it back down to their meaning. If you see molecular compound, you know a molecule is multiple atoms. A compound is different atoms. So molecular compound, combination of multiple atoms that are different. A molecular element, once again, molecule, multiple atoms. An element, the same atom. It has the same atomic number, the same number of protons. It's the same element. So therefore, it's just multiple of the same element coming together. So if we look up on here, if we have, for example, an example of H2O, which we've already used in an example. This is an example of hopefully you've said, a molecular compound, because we're seeing two different elements. Now, if I had something else, which was, for example, NaCl, this is just table salt. Once again, have a think what you might think it is. Hopefully you've come to the conclusion that this too is a molecular compound. I'll write MC underneath so you know what I've referred to. This is because we've got multiple elements here. There's two different elements, sodium and chloride, but they are different, which is what makes it a compound. So if we look down here, let's always remind ourselves that our molecular compounds, combination of multiple different elements, molecular element, multiple, just that they're the same. So the last thing that we're going to have a look at today is sort of what attracts or holds together atoms. Now, quite simply, at a Year 8 level, you do not need to understand the force or need to be able to explain the forces. Obviously, you have an understanding what a force is. But quite simply, what binds an atom together is this attraction between protons and electrons. So always remind yourself that protons are positive and electrons are negative. So, what keeps an atom together is the attraction between a proton and an electron. So if we remind ourselves, we have our big middle to our atom. It's a terrible circle. So we have in here our center, which is our this can take some time, I'm having to do it by touch and finger, nucleus. So this is our center point. Now we know that this is home to our protons and our neutrons, while our electrons are whizzing around on the outside. That's our structure of an atom. So it's the attraction between these two that keeps an element intact, or an atom intact. So remind yourself that a proton is positive while the electron is negative. Now, without this attraction, there's no reason for an electron to orbit the nucleus. What reason does it have? I mean, if we think back to our solar system, the reason why Earth orbits the sun is because gravity says so. The sun weighs a lot more than us, and therefore the gravitational pull of the sun keeps the Earth in a relative spherical orbit. So the same thing happens in atoms. The attraction between positive and negative is what binds together the atom and what keeps the electrons in orbit. So, all that I'll furthermore say is, for those out there who are interested, this force that does bind them together, obviously we're talking about electrostatic forces. Sometimes you'll see it as electronegative forces as well. Basically, you can see the word electros in there too. Basically remind ourselves that it is these positive and negative terminals that are attracting together. So as I said, this one was going to be quite short. Hopefully today I'll get up to balancing chemical equations as well. And that'll pretty much almost be the entire topic done. So as usual, if you do have any specific questions or you want me to go over anything further, please just comment it in on the YouTube comments. Thanks, boys.